Number 2 looks a lot like number 1, except this had an x. Here we've got an x squared. So let's take a look and figure out what's our u and our dv. Because again, regular u substitution doesn't work. We're left with the x squared stuff in there. It doesn't work out nicely. So that, as usual, like that u substitution is one of your first instincts. Check that. If it doesn't work, you have to fall back on different things, and this is one of those different techniques that might be helpful for certain problems. So just like before, we've got e to the 2x. That's more complicated than x squared. I'm going to go ahead and make that our dv. Right, the dv is going to be e to the 2x dx. And our u is just going to be x squared. So du, derivative of that, is just 2x dx. And then v is going to be the antiderivative of e to the 2x dx. Well, we can save ourselves some work. We already did that over here. And so I'm not going to bother going through that process again when I've already done the work. I know that's going to come out to be 1/2 e to the 2x. So our integral, since we're using integration by parts, that's going to be equal to u times v minus the antiderivative of v du. So u times v, we get 1/2 x squared times e to the 2x minus antiderivative of v du. Well, the 1/2 times 2, that just gives us 1. And we get x times e to the 2x dx. So we've got some bad news and some good news. Bad news is this integral, we can't use regular u substitution. If you notice, that integral is the same thing that we started off with in number 1. So that's our bad news. We can't evaluate that using regular u substitution or even without u substitution. We have to use integration by parts all over again. So like I told you before, sometimes that's going to happen. We're going to have to use integration by parts more than once. But I did say there's good news. Good news is we already did this, right? That we did this whole problem, and it comes out to be this answer. So luckily, since we did this, we don't have to go through all this work again. But let's say I didn't give you problem 1 to start with, and we started on number 2. We'd have to actually go through this whole process to figure out just this part. Yeah. Well, we're going to subtract that whole thing, but since this is just x and this is x squared, they're not like terms. All right, so we're going to go ahead and take care of this by substituting this whole thing in for this integral. But that minus is on the outside. We're going to go ahead and distribute that with everything. One thing we don't really need to distribute it with is the c, because we just generally put the plus c at the end. It could be minus c and it wouldn't really be wrong, but that's just kind of not the notation we usually see or use. So we end up with 1/2 x squared e to the 2x minus 1/2 x e to the 2x minus negative 1/4, so it becomes plus 1/4 e to the 2x. And like I said, I'm just going to leave it as plus c. If you put minus c, I wouldn't count that wrong.